I forgot to turn these back on. Hi, this is Ciarfox. Um, welcome to the stream. I know it's been a bit. I just decided I was going to rearrange a few things with the streams, so that's the reason why I stopped for the year. This is going to be one giant video on YouTube rather than trying to split it up. So that I had to like create thumbnails for all that and figure out what the best layout for all that stuff is, and it just became a bit of a trouble because I'm doing all this myself. So, anyways, we're gonna go ahead and start with things that are happening in space this year, so that y'all can find out. All right, kickstart 2025 with the Quadrantid's Peak, one of the best meteor showers all year. The very first weekend of 2025, so this weekend, offers up a flurry of wintertime astronomy, which I should remember to David Dickinson University today. Including a swift meteor shower, a January super sun, and a lunar planetary pair-up at dusk. January's Quid Watch. The Quadrantid meteors peak on January 4th, with a respectable projected zenithal hourly rate of 80. This is versus a 27% illuminated waxing crescent moon. Said slender moon won't hamper observations, making it 2025 an ideal for the quads. Prospects in 2025. The short peak arrives around 1500 to 1800 Universal Time on January 3rd, which favors the northern Pacific region at dawn. Keep in mind, it is still worth it for North American and European observers to watch on the morning of January 3rd and 4th. Before and after the peak arrives late. The obscure name for the Quadrantids is a remnant of the now defunct constellation Quadrans Muralis, the Mural Quadrant. This was divided up between Draco, Hercules, and Boots. Whoa! Where the present day radiant lies at the shower's maximum. When the modern constellations were formalized by the International Astronomical Union in 1928 and published in 1930. So, that. I think it's a great how an obscure piece of astronomical history turns up in a sky-watching discussions once a year. The source of the quadrants is a asteroid 2003 EH1, a rarity among meteor showers. Usually the number for that's right there is usually the year that it was found. If I remember correctly. The December Geminids have also a similar source rock. In Rock Comet... Okay, then I guess that's proving me wrong right there. 3200. Unless it was found there. Phaethon! Huh, I wonder if we've heard a lot of Phaethon recently. It's always been my experience that the quads, while they are a strong stream, are often elusive with a swift and brief peak. Maybe it's just because it tends to be brutally cold outside early January, cutting the observation window short. Be sure to dress warm and fill your travel mug with hot tea or cocoa, and keep those backup camera batteries toasty warm on your January Quadrant meteor quest. So that's from 2021. Earth at perihelion. Meanwhile, our homeworld reaches perihelion, or its closest approach to the sun, on January 4th at 0.98333 AU distance, around 13 Universal Time / 8 a.m. Eastern. It may seem ironic that we have actually reached our closest point in our orbit in the depths of northern hemisphere winter, Of course, it's currently summertime in the southern hemisphere. It's only true in our current epoch, as the eccentricity of the Earth's orbit, the the positions of the poles, and the process of equinoxes all change over time in what's known as the Mankovich cycles. The sun does indeed appear slightly bigger in January versus the aphelion in January. I mean, not January, July. 32 longitudinal, 32 latitudinal versus 3128 across an apparent size. We checked. Okay. And a great European occultation. Finally, the moon occults passes in front of Saturn on January 4th at 1724 Universal Time. The event favors Europe at dusk, and the moon is 25% illuminated, waxing crescent, and one of the best times to catch an occultation. This is the first planetary occultation by the moon in 2025. This should be a spectacular event as the planet disappears behind the dark limb of the moon and reappears behind the bright sunlit side. The rings will still be very visible, are headed towards the edge of the year, the edge this year on the March 23rd. In other words, we can't see them correctly because they're going to be, we'll be looking at them straight on. The rest of us get a consolation prize of seeing a close pairing on Saturn and the crescent moon at dusk worldwide. The moon occults Saturn twice in 2025, with the next and final event occurring on February 1st for the remote Canadian Arctic and Alaska. The International Occultation Timing Association lists the ingress and egress times located along the track for the January 4th event. And something more, clouded out or simply the wrong hemisphere. Astronomer, I am so sorry, Massey, will host no less than 3 virtual sessions this weekend, covering the meteors and the occultation. Oh, that's nice. We're not going to be doing it. Sorry, I might save them and then we could watch it for February. I need to remember. Saturn by the moon, and the moon's close pass near Venus on January 3rd, just 1 week prior to its greatest dusk elongation, 47 degrees east of the sun on the 10th. The moon joins an enthralling planetary parade this weekend, sliding by Saturn and Venus to the west at dusk. Meanwhile, Jupiter and Mars await their turn to greet the moon later in January to the east. Wherever you might happen to observe from this weekend, there's a sky watching event for you. Be sure to embrace the cold as we kick off another astronomy and sky watching in 2025. Alright, on to space exploration. Though some of the news we'll get from this is probably going to be like a year later, when they actually go through all the findings and get it set up into papers. Here's what to expect. Zibang, the conservation. In 2024, space exploration dazzled the world. NASA's Europa Clipper began its journey to study the Jupiter's moon Europa. SpaceX Starship achieved its first successful landing, a critical milestone for the future of deep space missions. China made headlines with the Shenzhou 6 mission, which successfully returned samples from the far side of the moon. Meanwhile, the International Space Station continued to host international crews. You know what? I'm gonna be... International crews. 1 second! When the, I have an announcement. Late March. Thought it was in February. Now it's late March. Okay. has pushed back the next astronaut cruise launch to the ISS from February to no earlier than late March to allow time for complete processing on a new SpaceX spacecraft that will be used for the mission. The 4 crew members aboard the space station must wait for the arrival of the next crew before they depart on a separate SpaceX Dragon capsule. They include NASA astronauts Suni Williams and Butch Wilmore, who landed on the Challenge Plague first flight test of the Boeing Starliner vehicle. The two originally intended to spend about a week in space station, but will wind up having lived and worked in orbit for more than 9 months, including the added time for latest delay. Sorry, I'm being distracted. New crews typically overlap with departing crews for a short time at the ISS, in which known as the handover period, during which astronauts can exchange information on ongoing science experiments, maintenance projects, and other protocols. Okay, when Williams and Wilmore finally do leave after the handover, I think one of them has a cat. The running joke is one of them has a cat, and their husbands, I think it might be Suni's husband's taking care of him, or their partner. Astronaut Nick Hague and Russian cosmonaut Alexei Gorbanov will fly home with them. Officials say the new Dragon capsule, expected to launch late March, should arrive at NASA's processing facility in Florida in early January. Fabrication, assembly, testing, and final integration of a new spacecraft is painstakingly endeavor that requires great attention to detail. Steve Stitch, NASA's commercial crew program manager, said in a statement. When the capsule launches a mission known as Crew 10, I wonder if it'll have its own... Well, it should, because that's what they always do, is have its own patch. Is expected to carry NASA astronauts Anne McLean and Nicole Ayers, Russian cosmonaut Kryly Peskov, and Japanese astronaut Takuya Onishi. Until then, the foursome will continue training their mission at NASA's Johnson Space Flight Center in Houston. Sorry, I know I got distracted by that. Nothing new. Meanwhile, the International Space Station continues to host international crews, including a private mission like Axiom Mission 3. As an aerospace engineer, I'm excited for 2025, when space agencies worldwide are gearing up for more ambitious goals. Here's a look at the most exciting missions planned for the coming year, which will expand the humanity's horizons even further, from the moon and Mars to asteroids and beyond. Yeah, science! How you doing, Vulture? We're going over the new stuff for 2025 space exploration, and then we have all this up here too. Hey, yeah, with Puppy, I'm happy Puppy is doing better. Give him hugs for me, and there is also a article about puppies in here, so either watch the replay or hang around for it. It's a bit further along. I think I have everything sorted. Because it's space, then I have a bunch of quantum ones. Well, space, then Earth, then a few quantum ones, and then biology, then archaeology, and then some human stuff. Scouting the lunar surface with CLIPS. NASA's Commercial Lunar Payload Services, or CLIPS, I know there's no I in there, but I'm going to say it anyways, initiated aims to deliver science and technology payloads to the moon using commercial landers. CLIPS is what brought Intuitive Machines' Odysseus lander to the moon on February 2024. That's when we started the... we did a watch party the day after. And that's what started this science streams because I was so excited and talking about it. Though, mind you, one of the things they didn't tell us during the thing is it fell over. But yeah, of course, it was successful. Ha! Marking the first U.S. moon landing since Apollo. In 2025, NASA has several CLIP missions planned, including deliveries by companies Astrobotic, Intuitive Machines, and Firefly Aerospace. These missions will carry a variety of scientific instruments and technology demonstrations to different lunar points. So we're trashing up the place already. Payloads will include experiments to study lunar geography, test new technologies for future human missions, and gather data on the moon's environment. By the way, in a sad sense of news, NASA's pushing back the actual we're supposed to re-land on the moon, but they're pushing that back again to some degree. Surveying the sky with Sphere X. On February 2025, NASA plans to launch the spectrophotometer for the history of the universe, epoch ionization and ice explorer, or Spheres observatory. This mission will survey the sky in near-infrared light, which is a type of light that is invisible to the naked eye, but that special instruments can detect. Near-infrared light is useful for observing objects that are too cool or too distant to be seen in visible light. Sphere will create a comprehensive map of the universe by surveying and collecting data on more than 450 million galaxies, along with over 100 million stars in the Milky Way. Astronomers will use this data to answer big questions about the origins of galaxies and the distribution of water and organic molecules in stellar nurseries, where stars are born from gas and dust. Hey, Wolfie Wolf! Studying low Earth orbit with Space Rider. The European Space Agency, or ESA, plans to conduct an orbital test flight of its Space Rider uncrewed spacecraft in the third quarter of 2025. Space Rider is a reusable spacecraft designed to carry out various scientific experiments in low Earth orbit. These scientific experiments will include research on microgravity, which is near weightless environment of space. Scientists will study how plants grow, how materials behave, and how biological processes occur without the influence of gravity. I guess a model of it, 3D model. The Space Rider will also demonstrate new technologies for future missions. For example, it will test advanced telecommunication systems, which are crucial for maintaining communication with spacecraft over long distances. It'll also test new robotic exploration tools for use in future missions on the Moon or Mars. Exploring the Moon with M2/Resilience. Japan's M2/Resilience mission, scheduled for January 2025, will launch a lander and a micro rover to the lunar surface. This mission will study the lunar soil to understand its composition and properties. Researchers will also conduct a water splitting test to produce oxygen and hydrogen by extracting water from the lunar surface, heating the water and splitting the captured steam. The generated water, oxygen, and hydrogen will be used for enabling long-term lunar exploration. This mission will also demonstrate new technologies, such as advanced navigation system for precise landings and systems to operate the rover anonymously. These technologies are essential for future lunar exploration and could be used in missions to Mars and beyond. The M2/Resilient mission is part of Japan's broader efforts to contribute to the international lunar exploration. It builds upon the success of Japan's Smart Lander for investigating the moon, or SLIM. Like I said, I love some of the names that they make up, or they put together just right to create the name of the mission, which landed on the moon using the precise landing technique on March 2024. I'm gonna slaughter this. I know I play Genshin and all those others, and I still mess up this Chinese names. Investigating the asteroid with Tianwen. 2. Tianwen-2 mission is an ambitious asteroid sample return and comet probe mission. Scheduled for launch in May 2025, Tianwen-2 aims to collect samples from a near-Earth asteroid and study a comet. This mission will advance scientists' understanding of the solar system's formation and evolution, building upon the success of China's previous lunar and Mars missions. I'm going to slaughter this name. I am sorry. The mission's first target is the near Earth asteroid 469219 Camio Elia. This asteroid is a quasi-satellite of Earth, meaning it orbits the Sun but stays close to the Earth. It is roughly 131 to 328 feet, or 40 to 100 meters in diameter, and may be a fragment of the Moon, injected into space by a past impact event. By studying this asteroid, scientists hope to learn about the early solar system and the processes that shape it. The spacecraft will use both touch and go and anchor and attach techniques to collect samples from the asteroid's surface. After collecting samples from the asteroid, Tianwen-2 will return to the Earth and then set course for its second target, the main belt comet 311P/Pan-STARRS. This comet is located in the asteroid belt between Mars and Jupiter. By analyzing the comet's materials, the researchers hope to learn about the conditions that exist in the early solar system, and possibly the origins of water and organic molecules on Earth. Solar system flybys! So there's a lot this year. Besides the above planned launch missions, several space agencies plan to perform exciting deep space flyby missions in 2025. A flyby, or gravity assist, is when the spacecraft passes close enough to a planet or moon to use its gravity for a speed boost. As the spacecraft approaches, it gets pulled in by the planet's gravity, which helps it accelerate. After swinging around the planet, the spacecraft is flung back into space, allowing it to change direction and continue on its intended path using less fuel. The Bepi Colombo, a joint mission by ESA and the Japan Aerospace Exploration Agency, JAX, will make its flyby of Mercury in January 2025. This maneuver will help the spacecraft enter orbit around Mercury by November 2026. BM Colombo aims to study Mercury's composition, atmosphere, and surface geology. One of the other articles we did a while back thinks that a lot of Mercury is actually diamond, which is in different places. I mean, that's a very vague overview of it, but NASA's Europa Clipper mission, which launched in August 2024, will make significant progress in its moon to Jupiter's moon Europa. In March 2025, the spacecraft will perform a flyby maneuver at Mars. I know, right? This maneuver, I think it's actually one of the title ones that I have on my channel when I still would split it up. The maneuver will help the spacecraft gain the necessary speed and trajectory for its long voyage. Later in December 2026, Europa Clipper will perform a flyby of the Earth, using Earth's gravity to further increase its momentum so it can arrive at Europa in April 2023. Think about that. Well, one of the other articles we had a bit before was talking about them using ion engines to speed up, so that it only takes like 6 months to get to Mars. But it's still in the theoretical phase to some degree, because they're only just starting to actually build a mini engine to see if it can actually work. The ESA's Herta mission, oh god, Herta Prime, or Prime Herta, will also perform a flyby of Mars in March 2025. Herta is part of the Asteroid Impact and Deflection Assessment mission, which plans to study the Dionysmos binary asteroid system. The mission will provide valuable data on asteroid deflection techniques and contribute. We do have another article on asteroid deflection techniques that we're going to read tonight. And contribute to planetary defense strategies. I forgot to turn off ads. I just realized. I am so sorry, y'all. Just realized it. Mission will provide valuable data on deflection techniques and contribute to planetary defense strategies. NASA's Lucy mission will continue its journey to explore the Jupiter Trojan asteroids, which share Jupiter's orbit around the Sun in 2025. One key event for Lucy is its flyby of the Inner Main Belt asteroid 52246 Donald Johansen. I wonder if that was the person who found it. This flyby will provide valuable data in this ancient asteroid's composition and surface features, which can help researchers gain insights into early solar system. The asteroid is named after the paleoanthropologist who discovered the famous Lucy fossil. ESA's Jupiter Icy Moons Explorer, or JUICE. Like I said, I love some of these names. Will perform a Venus flyby in August 2025. This maneuver will help JUICE gain the necessary speed and trajectory for its journey to Jupiter. Once it arrives, JUICE will study Jupiter's icy moons to understand their potential for harboring life. 2025 promises to be a groundbreaking year for space exploration. With NASA's ambitious missions and significant contributions from other countries, we are set to make remarkable strides in humanity's understanding of the universe. These missions will not only advance scientific knowledge, but also inspire future generations to look to the stars. Yeah, but they're, like I said, they keep on pushing, NASA keeps pushing back, actually landing on the moon with humans again and again, so it makes me feel like it's going to be like Mars, where they'll say, next generation, next generation, next generation will do it. Why don't I switch that over? New equation can reveal hidden asteroids set to strike Earth. If the Earth is going to be blown to bits by an asteroid, it'd be nice to have some advance warning to either do something about it or simply find peace in our impending doom. Woo! And a newly developed equation gives us a better chance of a early heads up. The work of physicist Oscar de Bronco-Novio from the University of Murcia in Spain takes the gravitational bending of light, GBL, something physicists have been grappling with for decades. As a result of this bending, objects aren't always what they appear to be out in space. The fundamental significance of our new equation is the high accuracy for the GBL angle calculation. We're going with math! The Barco-Novio. Knowing how light bends around the sun and other massive solar system objects means that we can more accurately track smaller objects in space, including dwarf planets, comets, and asteroids, headed straight for our planet. Oh my god. I know triangulate, you know, is you have to have a triangle in there, but I know all this. I actually made an A in geometry, so it kind of rings fun. Our study, which is based on geometric optics model, provides an exact equation for the most accurate calculation to date of the GBL angle by a static massive object such as the sun or solar system planets. The Barco-Novio. Yeah, I'm gonna still mess up the name every single time. This could have implications on the precise positioning of distant stars, as well as correct location of the solar system minor objects like asteroids, to better estimation of their exact orbits. Science greats such as Newton, Solideo, Darwin, and Einstein have identified and attempted to calculate GBL, but this new equation adds more accuracy than before. In part, this is done by incorporating finite rather than infinite distances for the numbers. More refined were made by adopting what's known as the material medium approach, which treats celestial objects in the same way as physicists would analyze simpler setups here on Earth. Like the way light bends as it passes through a glass of water, the Barcio Nuevo then verified his new equations through more complex numerical simulations, as well as comparisons to previous calculations. The relayed Sharpedo time delay formula. What's that? Sharpedo time delay effect, or gravitational time delay in effect, is one of the 4 classic solar system tests of general relativity. Radar signals passed near a massive object take slightly longer to travel to a target and longer to return than they would if a massive object was not present. The time delay is caused by time dilation, which increases the time it takes for light to travel a given distance from the perspective of an outside observer. Fun. Okay. Different branches of astronomy and astrophysicists, such as celestial mechanics or stellar dynamics, might benefit from this new result. Besides more accurately tracking asteroid orbits through the space, the equation could provide useful in multiple ways. It might give us a better look on Proxima Centauri, for instance, the next closest star to Earth after the Sun. It could also help with the Euclid mission currently undertaken by the European Space Agency. In the hunt for dark matter, it's charting the position of billions of galaxies in the cosmos, up to 10 billion light years away. It might be instrumental in finding a precise location of celestial objects in our solar system, and consequently, a better determination of their orbits around the Sun. The new research should therefore be important to astronomers and astrophysicists working on the ultra-precise astronomy measures, particularly in gravitational lensing studies. Alright. Massive grand design spiral galaxy found just 1 billion years after Big Bang. Back when the universe was new. Following the Big Bang, some 13.8 billion years ago, galaxies took a bit of time to assemble themselves from surrounding primordial soup. Sorry, I have to say it that way. A new discovery right at the end of the cosmic dawn is challenging how long we thought the assembly took. The James Webb Space Telescope, and I'll be just JWST from here on out, just so you know, has spotted a huge ultramassive galaxy as it appeared 12.8 billion years ago, so intricately structured that it can only belong to the most spectacular category of galaxies, the grand spiral design. Okay, it's an example right there. It's not the actual one. The galaxy's name is... I want to say Zhongli. Zhonglong, after the torch dragon of Chinese myth. And its discovery has been detailed in a paper uploaded to a preprint server at ARXIV, ahead of peer review publication. Zhonglong shows that mature galaxies emerged much earlier than expected in the first billion years after the Big Bang, writes in a team led by astronomer, oh god, Mingyang Zhao of the University of Geneva in Switzerland. Our findings offer key constraints for models of massive galaxy formation and the origin of spiral structures in the early universe. In the universe around us today, galaxies come in a number of different shapes and sizes. Lenticular galaxies are sort of bobby and formless, while spiral galaxies have a definite spiral arms curving out from their centers. The grand design spiral galaxy is the most magnificently structured sort of galaxy, with prominent, well-formed and visible spiral arms curving away from a bright, well-defined galactic center, almost the platonic ideal of what a spiral galaxy should look like. We don't have a clear idea about when spiral galaxies first started to come together in the universe, but they're pretty rare the further back in space-time we peer, and practically absent more than 11.5 billion years ago. Geelong was discovered serendipitously in a data collected by the telescope for its panoramic survey, an observation campaign to observe galaxies in the cosmic dawn, the first billion years after the Big Bang. Although the survey had spotted other massive galaxies, Geelong, the team says, truly incredible. It has strikingly evolved morphology, a quintessent like bulge plus star formation, stellar disk, plus grand design spiral arms, defined as spiral structures spanning the whole galaxy, from the nucleus to the outskirts, with spiral arms starting at the diametrically opposed points, already at 1 billion years after the Big Bang, they write in a paper. So this is it. In addition, it's quite large for a galaxy in the early universe, measuring some 62,000 light years in diameter, with a mass comparable to that of the Milky Way. The black hole in its center seems to be quiescent, suggesting that the star formation rate of between 20 to 155 solar masses per year is slowing. Altogether, the data indicates a galaxy that has gone through the throes of formation and settling down to a sedate, well-defined structure. Researchers believe that Zhonglong represents the earliest example of a spiral galaxy seen to date. This suggests that a Milky Way-like galaxy can form far faster than we thought, around 10 times faster than such formation would take place in the local universe. The presence of all these properties makes Geelong very exceptional, the researchers write, indicating the rapid formation and morphological evolution of mass galaxies in the early universe. Alright, flappiest solar system in the Milky Way just revealed a new planet. Have we talked about this one? I think we have. Some 2,600 light years from our own solar system dwells one of the most peculiar planetary systems in the entire galaxy, called Kepler 51. Yeah, I think this is one we've talked about. The sun-like yellow dwarf star was found in 2012 to have 3 exoplanets in its orbit. Each would turn out with a density lighter than cotton candy, putting them all in a rather adorably named category of super puff worlds. Super puff girls! Now astronomers have found a 4th. They're both thrilled and agog. Super puff planets are fairly rare, and when they do occur, they tend to be only one in a planetary system, says planetary scientist Jessica Libby Roberts of the Pennsylvania State University. If trying to explain how 3 super puff planets formed in one system wasn't challenging enough, we now have to explain the 4th planet, whether it's super puff or not. We can't rule out additional planets in the system either. Jigglypuff, yeah. Jigglypuff. The strange nature of the 3 known exoplanets orbiting Kepler 51 was established in 2019, when observations allowed for astronomers to make detailed measurements of the exoplanets' radii and masses. These measurements were turned into calculating their densities, which at less than 0.1 grams per cubic centimeter revealed the 3 worlds all fell under the category of super puff. A team of astronomers co-led by Libby Roberts and Kento Masuda, of Osaka University first got the hint that there might even be more in the system than meets the eye when they set out to catch one of those 3 exoplanets in transit. That's when exoplanets pass between us and its star, allowing us to make measurements of the planetary properties based on the faint dip in the star's light. Because of the orbital timings of the exoplanets have already been measured, this should have been pretty straightforward. But when they turned telescopes to the Kepler-51 to catch the transit with the Apache Point Observatory and the JWST, things didn't go according to plan. Thank goodness we started observing a few hours early to set a baseline, because 2 a.m. came, then 3, and we hadn't observed a change in the star's brightness. After frantically rerunning our models and scrutinizing the data we discovered, a slight dip in stellar brightness immediately when we'd started observing with the AOP, which ended up being the start of transit 2 hours early, which is well beyond the 15-minute window of uncertainty from our models. Cool. Something had to be awry, so this team scrambled to find out what it was. They carefully pored over data and transit timings obtained by the NASA's Planet Hunting Telescope, TESS, and archival observations from several ground-based telescopes. They also made new observations using Hubble and the Palomar Observatory. After carefully going back over their numbers to make sure no errors had been made, the only explanation that fit all the data was the presence of an unseen fourth exoplanet, gravitationally tugging the other 3 in an intricate orbital dance that influenced their transit timings. The fourth exoplanet would be named Kepler-51e. The other 3 are Kepler-51b, Kepler-51c, and Kepler-51d. If I remember correctly, they are losing their losing their gas at a higher rate than normal. Those super puffy planets. We conducted what's called a brute force search, testing out many different combinations of planet properties to find that the fourth planet model that explains all the transit data gathered over the past 14 years, Masuda explains. We found that the signal is best explained if Kepler-51e has a similar mass to the other 3 planets and follows a fairly circular orbit of about 264 days. Something we would expect based on another planetary systems. Other possible solutions we found involve a more massive planet on a wider orbit, though we think these are less likely. Since Kepler-51e hasn't been observed transiting, it's possible that its orbit is not aligned with our angle of observation. I can also make a kind of joke of, oh my god, it's a sovereign citizen saying that it's transiting. Sorry. Transits are required to calculate stellar radius, meaning we don't know how big it might be or what its density is. But just existing in a system with 3 super puff exoplanets is an oddity. More work will need to be done to figure out what the heck is going on with Kepler-51 system. One way to do that will be to peer into the atmospheres of the puffy transiting worlds and see what they're made of, which is what the work the team was trying to do in the first place. Yeah, that's one of the newer ones. These actually go together. Scientists found first radio burst to surprise source for the first time. When the magnetar within the Milky Way galaxy belched out a flare of colossally powerful radio waves in 2020, scientists finally had a concrete evidence to pin down an origin for fast radio bursts. A mind-blowing new study has now narrowed down the mechanism. By studying the twinkling light of a fast radio burst detected in 2022, a team of astronomers have traced the source of its powerful magnetic field around a magnetostar in a galaxy 200 million light years away. It's the first conclusive evidence that fast radio bursts can emerge from magnetospheres of magnet stars. In these environments of neutron stars, the magnet fields are really at the limits of what the universe can produce, says astrophysicist Kenzie Nimmo of the Massachusetts Institute of Technology. There's been a lot of debate about whether this bright radio emission could be even escape from that extreme plasma. Hi, Cat. Fast radio bursts, or RFBs, have puzzled scientists since they were first discovered in 2007. They are, as the name suggests, extremely brief bursts of radio emission, lasting just milliseconds. They are also extremely powerful, sometimes releasing more energy than 500 million suns in that brief blink of time. Cat, stop walking over that, please. Okay? FRBs are hard to study because most of the time they burst only once. This makes them impossible to predict, and tricky but not impossible to trace back to a source. A number of one-off FRBs have been traced to the galaxies across millions to billions of light years of space-time. Astronomers can also examine the properties of radio light, such as the polarization, to figure out what kind of environment it traveled through on its way to Earth. What kind of stars might emit FRBs is still largely a mystery, but a growing body of evidence increasingly implicates magnetars. Magnetars are particularly unusual neutron stars, in which themselves are the extremely dense core remnants of leftover after a massive star goes supernova. Hi, hello. You're smart too. But magnetars have much more powerful external magnetic fields than ordinary neutron stars, around 1,000 times stronger. They are most powerful magnetic fields in the universe. Around these highly magnetic neutron stars, also known as magnetars, atoms can't exist. They would just get torn apart by magnetic fields, says physicist Yoshi Masuai of MIT. Will suffer from compliments. You're amazing. You're cool. The exciting thing here is we found that the energy stored in those magnetic fields close to the source is twisting and configuring such that it could be released as radio waves that we can see halfway across the universe. To trace the origin of the FRB, Nimmo and her colleagues studied a property known as scintillation. In an event known as FRB 2022-110-22A, first detected in 2002 and subsequently traced to a galaxy 200 million light years away. No. Scintillation is what makes stars twinkle, the distortion of the path of light as it travels through gas and space. The longer the distance traveled, the stronger of the twinkling. Twinkle, twinkle, little star. Alright, FRB 2022-1022A. Ha! I'm not gonna say that 10 times fast, though. It's pretty bulk standard as far as FRBs go. It was moderately long, about 2 milliseconds, and moderately powerful. This makes an excellent case study for trying to understand the properties of other FRBs, too. A companion paper studying the polarization of light from that location, the degree to which the orientation of its waves is twisted, found an S-shaped angle swinging consistent with a rotating object. At first, for an FRB, this suggests that the signal originated from very close to the rotating object. Nimmo and the colleagues figured out that if they could determine the degree of scintillation, leading researchers to the gas region that distorted the signal, by using that gas region as a lens, they narrowed down the source of the FRB to within 1,000, I mean, 10,000 kilometers, or 6,213 miles, of its magnetar source. Zooming into the region from a distance of 200 million light years, it's like being able to measure the width of a DNA helix, which is about 2 nanometers wide on the surface of the moon, Matsui says. There's an amazing range of scales involved. It's the first conclusive evidence that extragalactic FRBs can originate from within the magnetosphere of a highly magnetized neutron stars. But it's more than that. The techniques used by the team show that scintillation may be a powerful probe for other FRBs, so astronomers can try and understand how diverse they might be, and whether other kinds of stars may also belch out the powerful eruptions. These bursts are always happening, Matsui says, and there's a lot of diversity of how and where they occur. A scintillation technique will be really helpful in disentangling various physics that drive the bursts. Alright, this is the second one that's covering this. I just wanted multiple sources. Actually, it seems pretty much the same. Well, similar. Recently, astronomers have made an astounding discovery. A mysterious and powerful burst of radio waves reached the Earth after traveling through space for 8 billion years. Dubbed the... We've already covered the name of it. It's one of the most distant and energetic radio signals ever observed. Fast radio bursts, including this particular one, are extremely intense flashes of radio waves that last only milliseconds, yet their origins remain a source of great intrigue and perplexity. We still don't know what or who sends these energy bursts. The nature of these signals challenges our understanding of the universe, as they can originate from regions far beyond our Milky Way galaxy, hinting at processes and events we can only begin to comprehend. Dr. Stuart Ryder, an esteemed astronomer of the Macquarie University in Australia, is among the dedicated team of scientists working diligently to unravel the mysteries surrounding this cosmic enigma. Through advanced technologies and collaborative efforts, they aim to decode the origins and implications of these fast radio bursts, potentially unlocking new insights into the fundamental workings of our universe and the forces that shape it. Yeah, us but cooler. Through advanced I already read that. Understanding fast radio bursts. Fast radio bursts, or FRBs, are the intense flashes of radio waves that last for milliseconds. They were first discovered in 2007, and ever since they have captured the curiosity and fascination of the scientific community worldwide. For instance, this recent FRB emits energy equivalent to what our sun produces over 30 years, all in less than a blink of an eye. Research speculate these cosmic events might be linked to magnestars, the highly energetic remains of what's left behind by exploding stars. Astronomers deployed the Australian Square Kilometre Array Pathfinder to detect the burst and track down its origins. We use the Ask AP radio dishes to skillfully pinpoint where the burst came from, says Dr. Ryder. The reveal didn't end there. The team also located the source galaxy using the European Southern Observatory's Very Large Telescope. Is that the name of it? That's hilarious. Discovering it's older and more distant than any FRB source found to date. Weighing the universe with FRBs. Believe it or not, these fleeting cosmic fireworks could help us weigh the universe. There are some discrepancies between the amount of normal matter we can detect and what cosmologists can theorize exists. Could the answer be outside our visual spectrum? More than half the matter that should exist today is missing, says Professor Ryan Shannon. He suggests that this missing matter might be hidden in the vast spaces between galaxies, where it's too hot and diffuse to see with conventional methods. Enter FRBs. Their unique ability to sense the ionized material in nearly empty space allows scientists to measure the matter located between galaxies. This method was established in 2020 by the late Australian astronomer Jean-Pierre Marquardt, also known as the Marquardt relation. This detection confirms that the Marquardt relation, even for bursts halfway across the known universe, adds Ryder. A new telescope will join the search soon. Nearly 50 FRBs have been tracked back to their origin, and about half were discovered using the ASK-AP telescope. Despite the unknown causes of these enormous bursts, the one thing is certain. FRBs are common events in the cosmos, and have enormous potential for advancing our understanding of the universe. Professor Shannon believes that the future radio telescopes currently under construction will detect thousands more FRBs. FRBs are common and hold great promise. We can use them to create a new map of the universe's structure and answer big questions about cosmology. Missing matter mystery. Missing matter mystery. Missing matter mystery. Missing. Sorry. The universe is enormous, and much of it still baffles us, especially the disparity between observable and theoretical material. This missing matter refers to a significant amount that should be there according to our current models of cosmic evolution, but hasn't been seen. It turns out that visible matter, like stars, planets, and galaxies, make up only about 5% of the universe's total mass energy content. The other 95% is thought to be dark matter and dark energy, which we can't directly detect. This gap raised some big questions about how the universe is structured and behaves. Researchers think that this missing matter might exist in the forms that are hard to spot, like hydrogen gas floating in the intergalactic medium. Recent studies with advanced telescopes have started to find these elusive hydrogen clouds, suggesting that a significant chunk of the universe's matter could be hiding in this diffused state. Figuring what this missing matter is and where it's located is key to getting the complete picture of the cosmic evolution and fine-tuning our models of how the universe works. Fortunately, the discovery of FRBs and their ability to trace hidden matter could revolutionize how we understand the cosmos. As Professor Shannon points out, even in near-empty space, the FRBs can see electrons and measure the matter present. Exciting future of FRB research. With more advanced radio telescopes on the horizon, the future of FRB research is looking bright. Each new detection brings us closer to unveiling the secrets of these powerful cosmic events. Beyond mapping the universe's structure, FRBs could guide us to fundamental questions about the inner workings of the universe, aligning us closer with the cosmic forces and events that shape our cosmos. Despite our growing knowledge base, FRBs remain one of the universe's greatest mysteries. As researchers venture deeper into the study of these cosmic flashes, the one thing became clear. We still know very little about the universe in which we live. Really? I wonder why. Alright. On to, stuff. Still space stuff. Probes and, Alright, NASA confirms Parker probe survives touching the sun in record-breaking flyby. In August 2018, NASA's Parker Solar Probe, PISP, began its long journey to study the sun's outer corona. After several gravity-assist maneuvers with Venus, the probe broke Helio 2's distance record and became the closest object to the sun on October 29th, 2018. Since then, the Parker probe's highly elliptical orbit has allowed it pass through the sun's corona several times, touch the sun, quote unquote. On December 24th, 2024, NASA confirmed that their probe made its closest approach to the sun, passing just 6 million kilometers or 3.8 million miles above the surface, roughly 0.04 times the distance between the Sun and the Earth. In addition to breaking its previous distance record, PISP passed through the solar atmosphere at a velocity of about 692,000 kilometers an hour, or 430,000 miles per hour. This is equivalent to about 0.064 speed of light, making Parker's solar probe the fastest human-made object ever. Whoosh! After the spacecraft made its latest pass, it sent a beacon tone to confirm that it made it through safely and was operating normally, which was received on December 26th. These close pass-bys allow that PISP to conduct science operations that would expand our knowledge of the origin and evolution of solar wind. PISP. Even flyby the probe made with Venus in the past 6 years brought it closer to the Sun in its elliptical orbit. As of November 6, 2024, the spacecraft reached an optimal orbit that brings it close enough to study the Sun and processes the influence that space weather the processes that influence space weather, but not so close to the Sun's heat and radiation would damage it. To ensure the spacecraft can withstand the temperatures in the corona, the Parker probe relies on carbon foam shield that can withstand temperatures between 980 and 1,425 degrees Celsius, which is 1,800 and 2,600 degrees Fahrenheit. The shield also keeps the spacecraft instruments shaded and at a room temperature to ensure they can operate within the solar atmosphere. Said Associate Administrator Nikki Fox, who leads the Science Mission Directorate at NASA headquarters in Washington, in a recent NASA press release, flying this close to the Sun is a historic moment in humanity's first mission to a star. By studying the Sun up close, we can better understand its impact throughout our solar system, including the technology we use daily on Earth and in space, as well as learn about the workings of a star across the universe to aid our search for habitable worlds beyond our home planet. Nor Rafai, the project scientist for Parker Solar Probe at the Johns Hopkins Applied Physicist Laboratory, is part of the team that designed, built, and operates the spacecraft. The Parker Solar Probe is braving one of the most extreme environments in space and exceeding all expectations. Yeah, that seems warm. I know, right? This mission is ushering a new golden era of space exploration, bringing us closer than ever to unlocking the Sun's deepest and most enduring mysteries. The Parker Solar Probe, which first proposed in a 1958 report by the National Academy of Sciences Space Science Board, which recommends a probe that passes inside the orbit of Mercury to study the particles and fields of the vicinity of the Sun. While the concept was proposed again in 1970s and 80s, it would take several more decades for technology and a cost-effective mission to be realized. The Parker Space Probe also made several interesting unexpected finds during previous close passes. During the first pass in the solar atmosphere in 2021, the spacecraft discovered that the outer boundary of the corona is characterized by spikes and valleys. Contrary to expectations, it also discovered the origin of switchbacks, zigzag structures, and the solar winds within the photosphere. Since then, the spacecraft has spent more time in the corona, closely examining most of the Sun's critical processes. The probe's discoveries are not limited to the Sun either. As noted, one of PISP's primary objectives is to study how solar activity influences space weather, referring to the interactive solar wind with planets of the solar system. For instance, the probe had captured multiple images of Venus during its many gravitational assists, documenting the planet's radio emissions. and the first complete image of Venus's orbital dust ring. The probe also has been repeatedly blasted by corona mass ejections, CMSs, that sweep up dust as they pass through the solar system. I remember we did another article that said that Venus's atmosphere is decreasing faster than what the Earth is, or what is of the atmosphere there. At a rate higher than expected. We now understand the solar wind and acceleration away from the sun. Adams, Gitzwell, Parker's solar probe mission scientists at NASA's Goddard Space Flight Center. This close approach will give us more data to understand how it accelerates closer. The probe even offers a new perspective on the comet Neowise. By capturing images from its unique vantage point. Now that the team mission knows the probe is safe, they are waiting for it to reach a location where it can transmit the data collected from its latest solar pass. The data will come down from the spacecraft will be fresh information about a place we, as humanity, have never been, said Joe Westlake, the director of Heliophysics Division at NASA headquarters. It's an amazing accomplishment. The spacecraft's next solar passes are planned for March 22nd, 2025 and June 19th, 2025. And it feels like this isn't a space, stream without having something about Voyager. Voyager 1 spacecraft phones home with transmitter that hasn't been used since 1981. The backup radio transmitter has remained dormant for about 43 years. Following recent communication issues, NASA's Voyager 1 spacecraft resorted to using a backup radio transmission that has been active since 1981. The Interstellar Explorer experienced a brief pause in communications after putting itself in a protective state to conserve power. This was triggered by a command sent on October 16th from NASA's Deep Space Network. A global array of giant radio antenna instructing the radio craft to turn on one of its heaters. The mission's flight team first realized there was an issue with Voyager 1 on October 18th, when the spacecraft failed to respond to that command. The team later discovered the spacecraft had turned off its primary X-band radio transmitter and instead switched over to its secondary S-band radio transmitter, which uses less power, according to a statement from NASA. The transmitter shutoff seems to be prompted by the spacecraft's fault protection system, which autonomously responds to onboard issues. NASA officials said in a statement, "The team is now working to gather information that will help figure out what happened and return Voyager 1 to normal operations." Voyager 1's fault protection system can be triggered for another number of reasons, such as if the spacecraft overdraws its power supply. If that happens, the spacecraft will turn off all non-essential systems to conserve power and remain in flight. After sending instructions to Voyager 1 on October 16th, the team expects to receive data back from the spacecraft within a couple of days. Normally it takes about 23 hours for... See, this is an older one, because I have a whole bunch of these that are actually older. And we're, since I wasn't doing them, I still kept them. Normally it takes about 23 hours to travel more than 15 billion miles, or 24 billion kilometers, to reach the spacecraft in interstellar space, and then another 23 hours for the space flight team on Earth to receive a signal back. However, on October 18th, the team was unable to detect Voyager 1 signal on the X-band frequency that the DSN antennas were listening for. This was because to use less power, the spacecraft's fault protection system lowered the rate at which the... Sorry, now have a cough drop. lowered the rate at which the radio transmitters was sending back data. The flight team was able to locate a signal later that day, but then on October 19th, the communication with Voyager 1 stopped entirely. When its X-band transmitter was turned off, the spacecraft's fault protection system is believed to have triggered twice more, ultimately causing it to switch to S-band radio transmitter, which prior to that date hadn't been used since 1981. Given the spacecraft is located much further away in interstellar space today than it was 43 years ago, the flight team was not sure a signal on the S-band frequency could be detected, especially because it transmits a significantly fainter signal when using less power. Cat, move. However, the team didn't want to risk sending another signal to the X-band transmission and triggering the fault protection system again. So instead, a command sent to the S-band transmission on October 22nd. 2 days later, on October 24th, the team was able to finally reconnect with Voyager 1. Now the team will investigate on what may have triggered the spacecraft's fault protection system in the first place. Given Voyager 1 should have ample power to operate the heater. However, it may be weeks before operators identified the underlying issue, according to the statement. Voyager 1, which was launched in 1977, ventured into interstellar space in 2012, the boundary of our solar system. Its time in deep space has taken a toll on its instrument and has caused an increasing number of technical issues. Earlier this year, the team had to fix a separate communication glitch, which was causing the spacecraft to transmit gibberish. While the spacecraft's advanced age and distance from the Earth can make maintenance challenging, Voyager 1 continues to return vital data from beyond the solar system. Alright, now into geology. Africa is splitting apart! A new ocean is forming faster than anyone predicted. A dramatic transformation is unfolding in Africa as tectonic forces drive the continent towards a formation of a brand new ocean. At the heart of its shift lies the Eastern African Rift System, a massive network of faults and fissures that is reshaping the region's geography at an accelerated pace. With tectonic plates separating faster than previously thought, scientists are uncovering surprising details about the future of this phenomenon. Sorry, that's how phenomenon is going to be said. But the full story of this impact on Africa's landscape and ecosystem is even more astounding. Could the timeline for this new ocean be closer than expected? The African continent is undergoing a dramatic transformation as the tectonic forces carve a path towards the formation of a new ocean. The East African Rift System, a vast network of faults stretching from Mozambique. Okay. How do you say that? Mozambique is what I'm thinking. But I am not gonna... Cat, stop. Are you gonna say it?
Mozambique.
I was correct! To the Red Sea, as the heart of this geological upheaval. Recent studies revealed that the region's tectonic plates are separating at an accelerated pace, potentially reshaping the continent's landscape and ecosystems in the coming millennia. This process, previously thought to span tens of millions of years, is now estimated to occur within 1 million years or even possibly sooner. The movement of the African and Somali plates, at approximately 0.8 centimeters per year, is driving the formation of a massive rift in East Africa. In the Ethiopian desert, this rift spans 60 kilometers and reaches the depths of 10 meters.
Hello, friend.
Hey, Maddox! Welcome to the science stream of the month. Yep, science! Such changes, while slow on a human timescale, mark an early stages of a significant geological event, the birth of a new ocean basin. Cynthia Binger of the Tulane University emphasizes the accelerating pace of this transformation. We've reduced the time frame to about 1 million years, possibly even half that. She notes that major seismic events, such as an earthquake, could further speed up the process, though predicting such occurrences with precision, somebody remains a challenge. Somebody didn't have a... Somebody read over this. That's repeating it. Somebody didn't have an editor. Echoes of the past, shaping a new ocean. The East African Rift's development mirrors the creation of the Atlantic Ocean millions of years ago, making it the only place on Earth where continental crust is transitioning into an oceanic crust, in real time. This rare opportunity allows scientists to study the intricate details of such transformation. Oh, at the beginning of the stream, it lists off there's supposed to be a meteor shower and a bunch of science-y space stuff happening this weekend. If you want to find out about that, if you want to go back now or not. This rare opportunity allows scientists to study the intricate details of such transformation. I already read that aloud, didn't I? Including the processes of governing the movement of tectonic plates and the formation of new geological features. In 2025, I'm not 2025. That's what we're in right now. In 2005, an event in Ethiopia underscored the rift's volatility. Over 420, ha ha ha. Earthquakes within a short period created a large fissure in the Afar region, an area characterized by its extreme temperatures and arid conditions. What would typically unfold over centuries occurred in mere days, challenging the long-held assumption about geological timescales. Implications for Africa's future landscape. The formation of the new ocean could dramatically alter Africa's geography. Landlocked countries like Zambia and Uganda may gain coastal lines, reshaping their economies and ecosystems. This shift underscores the dynamic nature of the Earth's surface and the interplay of natural forces that continue to redefine our planet. The potential impacts of a new ocean formation. Geographical changes, creation of new coastlines and the splitting of African continent, economic implications, emergence of new trade opportunities for previously landlocked countries, ecosystem shifts, formation of marine habitats in the newly developed ocean basins, infrastructural changes, adjustments required in land management and coastal infrastructure. However, these processes also present significant challenges for researchers. Accurate models predicting these changes, effectively monitoring techniques, and understanding the environmental impacts of a new ocean basin requires multidisciplinary collaboration. A call for innovative research. As the scientists study the implications of this tectonic activity, the accelerated timeline demands innovative approaches to understanding the Earth's geology. Ebinger and her peers are refining models for plate movement, seismic activity, and crustal transformation. Their work not only unravels the mysteries of this phenomenon, but also prepares the scientific community for the broader impacts of on the continent. Did a GBT write this? Because it keeps repeating over and over again. No offense. Or maybe all the offense. Who knows? Alright, this was given to me by Stargrasper. And I am so sorry I'm going to slaughter all this thing. Mysterious signal preceded the most powerful eruption of modern times. In January 2002, the most powerful explosion ever recorded with modern instruments rocked the South Pacific. Now scientists have identified a mysterious signal that preceded the thunderous event. Hong Tong Pai I am sorry, I repeat if I said that wrong. An underwater volcano in the Tongan archipelago erupted violently on January 15th, 2022. According to a new study, though, two faraway monitoring stations recorded a seismic wave some 15 minutes earlier. Authors of the study described the wave as a seismic precursor for the subsequent eruption, both of which were triggered by a collapse in a weak section of the oceanic crust below the volcano's caldera wall. This fracture led to both seawater and magma gushing into the zone between the seafloor and the volcano's underground magma chamber. The study authors explain, sparking in explosive eruptions. The fracture also caused a Rayleigh wave, and a type of acoustic wave that moves along a solid surface. In this case, Earth's surface. The wave was detected 15 minutes before the main volcanic eruption on January 15, 2002, from about 750 kilometers away, or 466 miles away. Early warnings are very important for disaster mitigation, says co-author Mi Ichihara, a volcanist at the University of Tokyo. Island volcanoes can generate tsunamis, which are a significant hazard. The volcano rumbled to life with a more modest convulsions in December 2021 and early January 2022, followed by the bigger eruption on January 14th, and then a record-shattering outburst the next day. The January 15 eruption has had a volcanic explosivity index rating of at least VI5, roughly on par with historic eruptions like Mount Vesuvius in 79 CE and Mount St. Helens in 1980s. It released 10 cubic kilometers or 2.4 cubic miles of volcanic material and sent 146 million metric tons of water vapor into the stratosphere, enough to fill 58,000 Olympic swimming pools. The explosion, equivalent to hundreds of atomic bombs, also caused the fastest underwater currents known to science. While that area is far from populated centers, the eruption sent out large tsunamis that killed at least 4 people in Tonga, as well as 2 in Peru, some 10,000, kilometers, or 6,200 miles away. Some of these. The eruption had a potential for far more death and destruction, however, and the next outburst from this or similar volcano could turn out to be much worse. And this is the... The hopes of learning more from this event before it happens, the study's authors analyzed seismic data from Rayleigh wave on January 15th, which was recorded by instruments in Fuji and Futuna. Rayleigh waves often are triggered by volcanic eruptions and earthquakes, but this one stood out, the researchers says. Their study suggested it was a precursor and possible sign of trigger for the eruption that occurred 15 minutes later. Many eruptions are preceded by seismic activity, says lead author Takuro Hirouchi, a volcanology graduate student at University of Tokyo. However, such seismic signals are subtle and only detected within several kilometers of the volcano. This Rayleigh wave quickly reached instruments on the islands hundreds of kilometers away, suggesting that a especially monstrous seismic event. We believe that unusually large movements started at the time of the precursor. The underground catalysts of volcanic eruptions have long been hidden from humans, though research like this proves insight that could end up saving lives, the researchers note. Every minute counts for issuing emergency alerts, and while this preceding Rayleigh wave couldn't be felt by humans on the ground, its detection by distant instruments bodes well for future forecasting, authors say. At the time of the eruption, we didn't think of using this kind of analysis in real time, Ichihara says. But maybe the next time there is a significant eruption underwater, local observatories will recognize it from their data. Same, my voice is already going, and I hate that. Might need to pare down some things. Where did I put the cough drops? 650-foot run-up. Mega tsunami in Greenland sends seismic waves worldwide. I might save some of this, like I said. That one's just a fun one. I think we can use some of the archaeology stuff. That one's a fun one. That one's just a fun one. Alright. On September 2023, a mega tsunami in Greenland triggered seismic waves worldwide, caused by a landslide in Dickinson Fjord. The event generated two seismic signals, a high-energy signal from the landslide, and a long-lasting VLP signal from a siege in the fjord. The findings offer new insights into the risks posed by climate change and landslides in Greenland. In September 2023, a massive tsunami in remote eastern Greenland triggered seismic waves that captured the attention of researchers worldwide. The event created a week-long oscillating wave in the Dickinson Fjord, according to a new report in the seismic record. Angela Cardio-Ponce of the GFZ, German Research Center for Geoscientists, and her colleagues identified two distinct signals in the seismic data from the event. One high-energy signal caused by the massive rock slide that generated the tsunami, and one very long period, or a VLP signal, that lasted over a week. Their analysis of the VLP signal, which was detected as far as 5,000 kilometers away, or 3,100 miles away, suggested the landslide and resulting tsunami created a siege, or a standing wave that oscillated in a body of water. In this case, the siege was churning for days between the shores of Dickinson Fjord. I think that's what happened with Crescent Bay in California. Or there was a different bay, or maybe it was one in Alaska, where it just basically kept going back and forth in it, sloshing. Yeah. The fact that the signal of a rock slide triggered sloshing waves in a remote area of Greenland can be observed worldwide, and for over a week is exciting. As seismologists, this signal was what mostly caught our attention. The analysis of the seismic signal can give us some answers regarding the processes involved, and may lead to improving monitoring of similar events in the future. If we had not studied the seismic event, then we would not have known that the siege produced in the fjord system, she added. Implications for climate change and future monitoring. The findings will help researchers as they study the impacts of landslides in Greenland and southern regions around the world, where global warming and the loss of permafrost are making rocky slopes and glaciers increasingly unstable. In western Greenland, recent tsunamis have been devastating consequences, such as the 2017 Karat Fjord event, where an avalanche caused a tsunami that flooded the village of I am so sorry. So sorry. Nagasaki and killed 4 people. Mega tsunamis over 100 meters or 330 feet high off the eastern coast of Greenland have also reached Europe. The September 16th, 2023 mega tsunami that took place in Dickinson Fjord. Is that the same one? Did they accidentally put 2023 rather? Oh yeah, it is still 2020. I was just, my mind was going on with the 2022 stuff that last article. Sorry! Mega tsunami took place in the Dickinson Fjord on a remote part of the eastern Greenland. It was first noted in social media posts and a report of waves hitting a military installation on Ella Island. Carrillo Ponce and colleagues studied both seismic signals and satellite imagery from the area to precisely locate and reconstruct the series of events. Their analysis of an initial high-energy seismic signal, combined with satellite images of a missing rock patch along a cliff along the Dickinson Fjord, allowed them to trace the direction of the landslide as it picked up glacial ice and became a mixed rock-ice avalanche before it reached the water. The resulting mega tsunami run up was more than 200 meters or 650 feet near the water entry point and an average of 60 meters or 200 feet along a 10 kilometer or 6-mile stretch of the fjord. Seismic signals and their lasting impact. While we were able to obtain information on the direction and magnitude of the force exerted by the landslide, we do not have the data to investigate the original cause of the landslide. The strength and radiation pattern and duration of the later seismic VLP signal best fit a scenario where the tsunami created a long-lasting siege in the fjords, the researchers found. The VLP signals have been observed previously in Greenland, but they are usually associated with iceberg collapse due to glacial earthquakes. In our case, we observed the VLP signal too, but the main difference is the long duration. It's quite impressive to see we could use good quality data from stations located as far as Germany, Alaska, and North America, and those records were strong enough to last for 1 week. The researchers say their approach might provide useful in studying similar past events and possible link to climate and environmental changes. We have to compare our results with remote sensing data to validate our solutions, and our study shows that the force produced by the signals is well resolved. Therefore, it becomes a useful analysis as seismic signals contain information on the type of source generating the signal and how the energy radiated. Alright. Quantum teleportation achieved over the internet for the first time. A quantum state of light has been successfully transported through more than 30 kilometers, around 18 miles of fiber optic cable amid a torrent of internet traffic. Them sending my food through, the internet. Woo! That's probably never gonna happen. Or something. The impressive demonstration by researchers in the US may not help you work to beat morning traffic, or download your favorite cat videos faster. However, the ability to teleport quantum states through existing infrastructure represents a monumental step towards achieving a quantum connecting computer system or network, enhanced encryption, or powerful new methods of sensing. This is it's incredibly exciting because no one thought it was possible, says Perm Kolomar, a Northwestern University computer engineer who led the study. Our work shows a path towards next-generation quantum and classical networks, sharing a unified fiber optic infrastructure, Basically, it opened the door to pushing quantum communications to the next level. Bearing a passing resemblance to Star Trek transport systems that ghost passengers across time and space in the blink of an eye, teleportation takes the quantum possibilities of an object in one location and, by carefully destroying it, forces the same balance of possibilities into a similar object in another location. Though the acts of measuring the two objects seal their fates in the same instance, the process of entangling their quantum identities still requires sending a signal of wave of information between points in space. Like fairy floss in the spring shower, the quantum state of any object is a hazy smear of possibilities, at risk of melting into reality moments after creation. Electromagnetic waves of radiation and thermal bumping and grinding of moving particles quickly reduces the quantum significance to decoherence if it isn't protected in some way. Shielding quantum states inside computers is one thing. Sending a single photon through optic fibers humming with bank transactions, cat videos, and text messages while protecting its quantum state is far more daunting. You don't text message through computers. You do that through phones, but okay. Might as well cast your quantum fairy floss into the Mississippi and hope it tastes as good at the end. I'm good. To preserve their lonely photon's previous state against 400 gigabytes per second current of the internet traffic, the team of researchers applied a variety of techniques that restricted the photon's channel and reduced the chances it might scatter and mix with the other waves. We carefully studied how light is scattered and placed our photons in a judicial point where the scattering mechanism is minimized, says Kumar. We found that we could perform quantum communication without interference from classical channels that are simultaneously present. While other research groups have successfully transmitted quantum information along classical data streams and simulations of the internet, Kumar's team is the first to teleport a quantum state along an actual internet stream. Excuse me. Each test suggests that quantum internet is inevitable, giving computer engineers a whole new toolkit for measuring, monitoring, encrypting, and calculating a world like never before, without needing to reinvent the internet to do so. Quantum teleportation has the ability to provide quantum connectivity securely between geographically distant nodes, says Kumar. But many people have long assumed that nobody would build a specialized infrastructure to send particles of light. If we choose the wavelengths properly, we won't have to build a new infrastructure. Classical communications and quantum communications can coexist. Continuing with the quantum stuff, quantum entanglement speed is measured for the first time, and it's too fast to comprehend. In the world of quantum physics, events unfold at mind-boggling speeds. Processes once thought to happen in an instant, like quantum entanglement, are now being examined in the tiniest fractions of a second. It's like freezing a fleeting moment to uncover a subtle detail hidden in plain sight. I'm gonna slaughter these names. Together with a team of researchers from China, Professor Joachim Bergdorfer and his colleagues from the Institute of Theoretical Physics in Tianjin are measuring these fleeting moments to understand how quantum entanglement actually happens. These scientists aren't focused on the existence of quantum entanglement, but are keen to uncovering how it begins. How exactly do two particles become quantum entangled? Understanding quantum entanglement. Using advanced computer simulations, they've managed to peek into the processes that happen on an attosecond timescale. I had never heard of an attosecond until now. A billionth of a second. Damn. Quantum entanglement is a strange and fascinating phenomenon where two particles become so interconnected that they share a single state. It's like having two magic coins that are always land on the same side. Flip one and the other mysteriously shows the same result, even if it's miles away. You could say that the particles have no individual properties. They only have common properties. From a mathematical point of view, they belong firmly together, even if they are in two completely different places, explains Professor Bergdorfer. If this means that measuring one particle instantly affects the state of the other, no matter how far apart they are. In simpler terms, entangled particles share a connection that lets them talk to each other simultaneously. Measure one particle, and you'll immediately know something about its partner. This strange behavior defines our everyday understanding of how the world works, making entanglement one of the most mind-boggling concepts in quantum physics. Experimenting with lasers and electrons, as incomprehensible as the concept of quantum entanglement seems, it's no longer a matter of debate whether it's true or not. And that's not what this study is about. We, on the other hand, are interested in something else, finding out how this entanglement develops. In the first place, in which physical effects play on the role of extremely short timescales. I'm so sorry about messing up these names. I'm going to say that so many times. Professor Iva Brezhonov, one of the authors of the current... It has a lot of symbols above each one of the letters, and Helms knows I've failed phonics as it is. To explore this, the team looked at atoms struck by an extremely intense high-frequency laser pulse. Imagine shining a super-powered flashlight on an atom. One electron gets so excited that it breaks free and flies away. If the laser is strong enough, a second electron inside the atom also gets a jolt, moving to a higher energy level and changing its orbits around the nucleus. After this intense blast of light, one electron is off on its own, and the other is left behind, but not quite the same as before. We can show you that these two electrons are now quantum entangled, says Professor Bergdorfer. That you may analyze them together. Then you can perform a measurement on one of the electrons and learn something about the other electron at the same time. When time gets fuzzy-wuzzy. Timey-wimey. Sorry. Doctor Who quote! Timey-wimey. This is where things get really intriguing. The electron that flies away doesn't have a definite moment when it left the atom. This means that the birth of time of the electron that flies away is not known in principle. You could say that the electron itself doesn't know when it left the atom. I didn't realize that it had enough sentience to do that, but okay. In what's called quantum superposition, yeah, means it exists in multiple states at once. But there's more. That time when the electron departs is linked to the energy state of the electron that stays behind. If the remaining electron has a higher energy, the departing electron likely left earlier. If it's a lower energy state, the electron probably left later, on the average of around 232 attoseconds later. Measuring the unmeasurable. An attosecond is so brief that it's beyond the ability for most people to understand. Yet these tiny differences aren't just theoretical. These differences can only be calculated, but also measured in experiments. The team has devised a measuring protocol combining two different laser beams to capture this elusive timing. They're already collaborating with other researchers eager to test and observe these ultra-fast entanglements in the lab. Why does quantum entanglement matter? Understanding how entanglement forms could have big implications for quantum technologies, like cryptography and computing. Instead of just trying to maintain entanglement, scientists can now study its very inception. This could lead to new ways of controlling quantum systems and enhancing the security of quantum communications. The journey doesn't stop here. Professor Bergdorfer and his team are excited for the next steps. Say it. differently every time I say it. We're already talks with researcher teams who want to prove such ultra-fast entanglements, he shares. By exploring these ultra-short timescales, they're not just observing quantum effects. They're redefining how we understand the very fabric of reality. Quantum entanglement and the future. It is clear that in the quantum world, even the briefest moments hold a wealth of information. The electron doesn't just jump out of the atom. It is a wave that spills out of the atom, so to speak, and it takes a certain amount of time, explains Iva Nova? Sorry again. It's precisely during this phase that the entanglement occurs, the effect which then precisely measured later by observing the two electrons, she concludes. So next time you blink, remember that in less than a trillionth of that time, entire quantum events are unfolding, revealing the secrets of what could change the future of technology and our understanding of the universe. Alright, evidence of negative time found in quantum physics experiment. Quantum physics are familiar with the wonky, seemingly nonsensical phenomenon, timey-wimey. Atoms and molecules sometimes act as particles, sometimes as wave. Particles can be connected to one another by a spooky action at a distance, even over great distances, quantum entanglement we were just covering, and quantum objects can detach themselves from properties like the Cheshire cat from Alice's Adventures in Wonderland detached itself from its grin. Now, researchers led by Daniela Angelo of the University of Toronto have revealed another oddball quantum outcome. Photons, wave particles of light, can spend a negative amount of time zipping through a cloud of chilled atoms. In other words, photons can seem to exit a material before entering it. It took a positive amount of time, but our experiment observed the photons can make atoms seem to spend a negative amount of time, and the excited state is up. Wrote Farah Steinberg, a physicist at the University of Toronto, on in a Twitter post about the new study, which was uploaded to the preprint server arxiv.org on September 5th and has not yet been peer-reviewed. The idea for this work emerged in 2017. At the time, Steinberg and a lab colleague, then doctoral student Joshua Sinclair, were interested in the interaction of light and matter, specifically a phenomenon called atomic excitation. When photons pass through a medium and get absorbed, electrons swirling around the atom in that medium jump to higher energy levels. When those excited electrons lapse to their original state, they release that absorbed energy as re-emitted photons, introducing a time delay in the light's observed transit time through the medium. Sinclair's time wanted to measure the time delay, which is sometimes technically called group delay, and learn whether it depends on the fate of that photon. Was it scattered and absorbed inside the atomic cloud, or was it transmitted with no interaction whatsoever? At the time, we weren't sure what the answer was, and we felt like such a basic question about something so fundamental should be easy to answer, Sinclair says. But the more people we talked to, the more we realized that while everyone had their own intuition or guess, there was no expert consensus on whether the right answer would be. Because of the nature of these delays can be so strange and counterintuitive, some researchers had written off the phenomenon as effectively meaningless for describing any physical property associated with light. Is that how short? I was saying, nope, they're just doing the editor thing. After 3 years of planning, his team developed an apparatus to test this question in the lab. Their experiments involving shooting photons through a cloud of ultra-cold rubidium atoms. Rubidium atoms. I'm not sure if I'm saying that right. Measuring the resulting degree of atomic excitation. Two surprises emerged from the experiment. Sometimes photons would pass through unscathed, yet the atoms would still become excited, and for just as long as if they had absorbed those protons. Stranger still, when photons were absorbed, they would seem to be readmitted almost instantly, well before the atoms returned to their ground state, as if the photons, on average, were leaving the atoms quicker than expected. The team collaborated with Howard Wiseman, good name, a theoretical and quantum physicist at Griffith University in Australia, to devise an explanation. The theoretical framework that emerged showed that the time these transmitted photons spent is as an excited excuse me. The theoretical framework that emerged showed that the time these transmitted photons spent as an atomic excitation matched perfectly with the expected group delay acquired by the light, even for cases where it seemed as though the photons were readmitted before the atomic excitation had ebbed. To understand this nonsensical finding, you can think of photons as fuzzy quantum objects, fuzzy wuzzy, as they are, in which any given photon's absorption and readmission through an atomic excitation is not guaranteed to occur over a certain fixed amount of time. Rather, it takes place across a smeared out probabilistic range of temporal values. As demonstrated by the team's experiments, these values can encompass instances when an individual photon's transit time is instantaneous, or bizarrely, when it concludes before the atomic excitation has ceased, which gives it a negative value. I promise you that we were completely surprised by this prediction, Sinclair says, referring to the matchup between the group delay and the time when the transmitted photons spent as atomic excitations. And as soon as we were confident we hadn't made a mistake, Steinberg and the rest of them had moved on to do a postdoctorate at the Massachusetts Institute of Technology by this point, and began planning to do a follow-up experiment to test this crazy prediction of negative dwell time and see if the theory would hold up. That follow-up experiment, one led by Angelo that Steinberg touted on Twitter, can be understood by considering the two ways a photon can be transmitted. In one, the photon wears blinders of sort and ignores the atom entirely, leaving without even a nod. In the other, it interacts with the atom, boosting it to a higher energy level before getting readmitted. When you see a transmitting photon, you can't know which of these occurred, Steinberg says, adding that because photons are quantum particles in a quantum realm, the two outcomes can be superpositioned. Both things could happen at the same time. The measuring device ends up in a superposition of measuring zero, which means measuring some small positive value. But correspondingly, Steinberg notes, that also means that sometimes the measuring device ends up in a state that looks not like 0 plus. Something, not like 0 or something that's positive, but like 0 minus something positive, resulting in what looks like the wrong sign, a negative value, for this excitation time. The measurement results in Angelo and her colleagues' experiment suggesting that the photons move through the medium faster when they excite the atoms than when the atoms remain in their ground state. The photons aren't communicating information, so the outcome does not contradict the nothing can travel faster than light speed limits set by Einstein's special theory of relativity. A negative time delay may seem paradoxical, but what it means is that if you build a quantum clock to measure how much time the atoms are spending in an excited state, the clock hand would, under certain circumstances, move backwards rather than forwards, Sinclair says. In other words, time in which photons were absorbed by atoms is negative. Even though the phenomenon is astonishing, it has no impact on our understanding of time itself. But it does illustrate once again that the quantum world still has surprises in store. Angelo and the rest of the team have accomplished something really impressive and produced a beautiful set of measurements. The results raise interesting questions about the history of photons traveling through absorptive media and necessitate a reinterpretation of the physical meaning of the group delays and optics, Sinclair says. See if I can get through this without them, stopping me. Meet the world's oldest fish, presumed extinct for 60 million years, then rediscovered in a small fishing town. Prior to 1938, sounds like a side quest. I know, right? If you ask us geologists to name some of the oldest fish known to science, you'd probably hear about an oddly named lobefish known as the coelacanth. The name sounds ancient. I'm not saying it correctly, apparently. Coelacanths first evolved into existence during the early Devonian period, a little over 400 million years ago. The Devonian period was also around the time that there was so much more different types of species. Like, there was an extinction event, and coelacanth? Coelacanth? Yeah, probably. What this zoologist would not have told you is that this ancient fish could still be found in the ocean today. In fact, they probably would chuckle at the idea. Scholars prior to the rediscovery in 1938 presumed that they had gone extinct during the late Cretaceous period. Yeah, it survived the Cambrian extinction event, I think is what it's called. Cretaceous period, 65 to 70 million years ago. Here we go! More of me slaughtering names! The coelacanth, I guess. Free real estate. Is an example of Lazarus taxon, an animal that seemingly disappears from the fossil record, only to be rediscovered in its same form millions of years later. This could happen for a number of reasons. More often than not, it highlights how sporadic and incomplete the fossil record is, especially when the number of individuals in a given taxon is low. In the case of the this fish, the zoological community was upended in 1938 when a 32-year-old museum employee, Marjorie Courtenay Latimer, working in the small African town of East London, was presented with a fish that could not be identified. It was caught by a local fisherman while fishing outside the mouth of the Kalumana River in eastern Cape of South Africa. She couldn't identify the fish either, so she had it taxidermied and sought out the opinion of an expert, Professor James Leonard Bury Smith. These names! The university lecturer and an expert in marine life. When Bury Smith received Latimer's sketch and notes on the identified fish by mail, he responded via telegram with a now famous message. Most important, preserved skeleton and gills. Fish described. When Bury Smith arrived in East London, he confirmed his hunch. The fish was indeed an ancient I will remember how to say this properly when I'm trying to sleep tonight or in the morning. It was a discovery that sent shockwaves through the zoological community, earning both Brierly Smith and Courtenay Latimer international recognition. Interestingly, a second specimen was discovered for another 15 years. I mean, I sleep sometimes. It's I love my sleep schedule. In that it's non-existent. The second coelacanth was found in 1952 by two fishermen of the Comoro Islands, a small island chain nestled between Madagascar and the mainland Africa. In 1990s, the scientists made another noteworthy discovery, finding the second species of coelacanth in the Indonesian islands. Thus it stands today. Coelacanth falls in one of two species. The West Indian Ocean, Latamira colony, primarily found near the Comoro Islands off of east coast of Africa, and the Indonesian coelacanth, Lamira Denisis. Here's one of the few reasons why the ancient fish have been able to stand the test of time. Adaptations. They have a number of unique physiological traits that have suited them well over millions of years. For instance, their lobbed pectoral fins, which are thought to be precursors to limbs of terrestrial vertebrates, are well adapted for maneuvering in deep, complex underwater environments. Stable environments. The fish inhabit deep, stable environments, like underwater caves in the deep sea, which have not changed much over geological time. These environments have few predators and less competition, helping the fish avoid drastic evolutionary pressures. Low metabolism. These fish have a relatively low metabolic rate, which allows them to survive in environments where food may be scarce. Their slow metabolism contributes to their ability to withstand long periods of environmental change. Special niche. Their ecological niche, typically in deep, cold waters, hasn't changed much. The stability in their habitat means they face less pressure to adapt compared to species living in more variable environments. Overall, the combination of evolutionary adaptations, environmental stability, and specialized ecological niche have helped it persist through significant changes in the Earth's history. Alright, on to more biology. I mean, that was biology, but I mean, it was more or less a history lesson too. Achilles' heel of drug-resistant bacteria has been found, scientists say. New tactics in controlling infection are sorely needed, with antibiotic-resistant bacteria expected to claim as many as 2 million lives each year by 2050. U.S. and Spanish researchers have now discovered at least some bacteria pay a steep price for their resistance, a cost that we may be able to exploit to fight the infection. We discovered an Achilles' heel of antibiotic-resistant bacteria, says molecular biologist Gordel Seal from University of California. I'm so sorry. I slaughtered these names. We can take advantage of this cost to suppress the establishment of antibiotic resistance without drugs or harmful chemicals. Exploring why bacteria with resistant factors don't necessarily dominate their non-resistant relatives. The University of California, San Diego biologist Une Chai-moon and colleagues discovered an example of protection that comes at a cost, impeding the bacteria's ability to survive when levels of magnesium are low. While we often think of antibiotic resistance as a major benefit for bacteria to survive, we found that the ability to cope with magnesium limitation in their environment is more important for bacterial proliferation. Depriving the environments of magnesium could counter the bacterial's ability to thrive, and because unmutated strands don't share the same flaw, reducing the key nutrient shouldn't adversely impact bacteria needed for a healthy microbiome. Charged metal like magnesium ions stabilize ribosomes, the micro machines in the cells that create proteins. The ions also play an important role in the use of ATP that powers our cells. Mitochondria is the powerhouse of the cell. Immune version of the L22 ribosome in some Bacillus subtilis both protects the strain against antibiotics and tightly binds the charged magnesium atom, leaving less for ATP to use for producing cellular energy. Moon and Dahim's model revealed that this physiological toll impedes the mutated strand's ability to grow and spread, compared to the unmutated B. subtilis. Intracellular competition for a finite magnesium pool can thus suppress the establishment of an antibiotic-resistant ribosome variant, the researchers write in their paper. This means without the pressure of antibiotics, unmutated subtilis is fitter than the antibiotic resistant B. subtilis. We showed that through a better understanding of the molecular and physiological properties of antibiotic-resistant bacteria, we can find novel ways to control them without the use of drugs. A limited comparison reveals that not all mutated ribosome variants have this weakness, so the researchers are keen to explore similar mechanisms in other bacteria as well. We hope that our work can help to identify conditions that hinder antibiotic-resistant strains without the requirement of new antibiotics. Okay, this is a fun one, because I am strange. I'm gonna get rid of some of this because my voice is going. Scientists solved the centuries-old mystery of how cucumber explosively squirts its seeds. Come on. An odd little gourd called the squirting cucumber has an explosive reproductive strategy that has intrigued naturalists since the days of the Roman Empire. Squirting cucumbers blast their seeds over distance, hundreds of times their length, and now scientists know how the plants do it. A squirting cucumber is in action is a remarkable sight, but if you blink, you might miss it. Eruptions last about 0.03 seconds, or 30 milliseconds. When ripe, the hairy green fruit measures about 1.6 inches. You can make the... I know. Centimeters long. As it drops from a stem, it launches a fountain of seeds and sticky liquid at the velocity of about 45 miles per hour, 20 meters per second, with the seeds reaching a distance of about 33 feet, or 10 meters. Squirting cucumbers, also known by the scientific name of Ecbelium elaterium, are found across the Mediterranean. I mean, it is CNN, and we always have to question places like CNN. Mediterranean and Europe, in parts of northern Africa. Yeah, we always have to question large news networks. Australia, Asia, and North America. They are members of a gourd family, Cucurbitaceae, and relatives of the zucchini, squash, and pumpkins, but their seed jets are unique to the group and rare among plants. The ancient Roman naturalist Pliny the Elder, AD 23 to 79, was the first to describe squirting cucumbers, warning that the seeds spurt out, even endangering the eyes. Studies in the 19th century provided clues about the cucumber's high pressure internal launch system, but until now, the details of their seed spurts were poorly understood. Probably. Recent researchers blew this ballistic mystery wide open. They used high-speed video, time-lapse photography, CT scans, and digital 3D reconstruction to analyze squirting cucumbers before, during, and after squirt, and created a mathematical model to describe the fruit's geyser-like eruptions. Their findings, published Monday in the Journal of Proceedings of the National Academy of Sciences, explain that the squirting mechanism is more complex than the simple buildup of liquid and release of internal pressure. Along with the cucumber engorgement, Other physical changes in the plant before and during the explosion shaped the angle, height, and distance of a successful seed spew, according to this study. It's a new idea that optimal seed dispersal is not only about the building of the greatest pressure in the fruit, said Angela Hay, research group leader at the Max Planck Institute for Plant Breeding Research in Cologne, Germany. Hay had previously written about explosive seed dispersal, but it was not involved in the new research. Rather, Hay told CNN in an email, the study suggests that the most effective seed launch relies on a trade-off between pressure from the fluid accumulation and other distinct changes that prepare the fruit for that eruptive moment. I know, I love it. Yeah. Oh yeah. Oh yeah. Sign permission slips. Yeah. A tiny little squirt. Study co-author Dr. Derek Moulton, a professor of applied mathematics at the UK's University of Oxford, was introduced to the squirting cucumbers in the summer of 2022 by senior study author Dr. Chris Thorogood, a deputy director and head of science at the Oxford Botanic Garden and Arboretum. Go on with the Thorogood brought Milton and the other researchers to see squirting cucumbers in the Oxford Garden, assuring them that the unassuming gourds were more bizarre than they looked. When they were ripe, all it took was a touch to trigger their high-powered launch. He bent down and gave one a squeeze, and you could hear the tiny little squirt, but we couldn't see anything happen because it was too fast, Moulton said. So he took some fruits back to the lab where we filmed the ejection with high-speed cameras. It was amazing. We were hooked, and we wanted to understand it. High-speed videos of the cucumbers were just beginning. Researchers used CT scans to study the internal arrangements of the seeds. This tested the stiffness of plant parts and captured time-lapse videos in the days leading up to a seed launch to track physical changes in the stems and fruits. With mathematical models based on their data, the scientists created simulations of seeds taking flight and predicting where they would land. Our mathematical framework came from thinking about the physics of the process both before and during the seed ejection, including mathematical descriptions of both the fruit and stem and how they interact, Moulton says. Lift and twist. Results of a CT scan. Days before a seed launch, a lot is going on inside the cucumbers. The researchers observed as the fruit swelled with fluid. Some of that fluid also flowed into the stem, thickening and stiffening it so that the dangled fruit would be lifted from a near vertical hanging position to an angle of about 45 degrees. Squirting from this angle rather than straight up is a better strategy for the plant, enabling it to spit the seeds further, according to the study. The scientists also saw that the stem gave the fruit a spin as it detached by shrinking away from the fruit. Their model shows that the spin would disperse the seeds in a wider arc. It's not just enough to fire your seeds far. You also want them to well spread out if you want to increase the likelihood of some of them to survive to make new plants, Moulton said. There was this whole orchestra of activity that contributes to where the seeds go. And since all that detail lived in our mathematical model, we're able to show how fine-tuned the ecbolicum is for successful dispersion. Scientists often look to model organisms, certain species that are well studied, to answer biological questions. But there also is so much to be learned from studying outliers that receive less attention, such as the squirting cucumber, Hayes says. Any interesting traits are not found in model organisms, she said. This paper shows how we can learn from diversity. The new study also illustrates that even though plants typically don't command center stage for odd behavior, they can also demonstrate some pretty amazing feats, Moulton said. How many people have ever associated cucumbers with rapid motion, he asked. I was quite happy to be able to uncover something about the mechanism of this fascinating little cucumber. Running Doom on E. coli cells very, very slowly. It would take nearly 600 years to finish playing this MIT student's iteration of the video game classic. Its programming question is nearly as old as the inspiration itself. Can it run Doom? Released over 30 years ago, the seminal first-person shooter is a touchstone classic of video gaming, not only for its influence on the medium, but for inspiring some pretty wild coding schemes. In 1997, Doom's creator at ID Software released the game's original source code for free online, allowing legions of hobbyists the ability to tinker and experiment with their Doom-slaying heart content. Since then, enthusiasts have hacked an ever-expanding list of devices to play the pixelated sci-fi horror game. From pregnancy tests, to tractors, to ATMs, to calculators. If it's got at least some circuitry in it, chances are, with little ingenuity, it can run Doom. And now the circuitry apparently extends to gut biome bacteria. Lauren Ramlan, an MIT biotechnology PhD student researcher, recently released a paper documenting a truly stomach-turning feat. Ha ha ha, because it's gut biome bacteria. As highlighted by Rock, Paper, Scissors, Shotgun, she programmed Doom to run on a display made from E. coli cells. To run Doom, all one needs is a screen and willpower, Ramlan writes. Ultimately, this begs the question of how biological systems might be engineered to host this classical millennial first-person shooter. According to Ramlan, for the project to work, E. coli cells must function as traditional pixels, capable of being either on or off. They also need to collectively light up in a form of images like the computer monitor or a TV screen. To make that happen, Ramlan first grew cells within a 32 by 48 1-bit well plate, then connected the makeshift screen to a controller capable of processing and translating binary code into addition or omission of a repressor controlling the fluorescence of the cells. Basically, Ramlan swapped the traditional screen's light dot diodes for glowing bacterial cells. Alright. This is the Doom screen. So, that's the A, the original frame of Doom. B is the 32 by 48 grayscale compressed first frame of Doom. And C is the threshold of the 32 by 48 array that's used to determine which pixels are on or which are off. While likely a tall endeavor to the average layperson, Ramlan made it happen by combining an aforementioned willpower along with some dizzying coding and organic chemistry skills. The result is a functioning display of the screen of luminescence E. coli capable of showing off Doom in real time. Sort of. Ramlan's invention reportedly takes roughly 70 minutes to fully illuminate, and then another 8 hours and 20 minutes to dim back to its original state. All told, that's basically about 9 hours to offer players a single frame of the video game. Given that the original Doom tops out at 35 frames per second, it would take quite a while to actually play through the entire game. Like, 599 years a while, according to the calculations. This is amazing find because it means we are a small handful of generations away from the peak of human engineering, where doom and life become one, she deadpans in her explainer video. May not be the most efficient way to starve off demon hordes of Mars, but it certainly is a more creative one yet. Alright. Dogs' brains sync with ours when we gaze into their eyes, study finds. If you ever gazed into the big watery eyes of a dog and suddenly felt connected, you might have be experiencing a moment of brain synchronization. For the first time, researchers in China have found neural activity syncing up between two different species, humans and dogs. The findings suggest we really do bond with our pets on a deeper neurological level. Previous studies have shown that when humans are talking or working with another, our brain activity in key regions can sync up. But this is the first series of experiments to report similar phenomena between humans and other species. The researchers measured brain activity in humans and dogs by placing electrodes on their skull. For the trial, 10 young beagles were matched with unknown humans, and the pair got to know each other over the course of 5 days. In the experiments, the human-dog pairs engaged in non-verbal communication, such as mutual gazing or a good old pat. As a control, the human and dog also stayed in the same room and did not interact. We observed the inner brain correlations in the frontal and parietal regions dramatically increased during mutual gaze, the authors of the studies write, led by biologist Wei Rin from the Chinese Academic of Sciences. When human participants were just petting the dogs, the team observed similar patterns of synchronization. But in this case, the synchronity was stronger in the parental. I said it correctly a second ago. Frontal and parietal, a load of brain region. In humans, the activity in both the frontal and parietal brain regions is associated with joint attention. Previous studies have found that when humans pet their dogs, their frontal lobe activity spikes, which suggests that they're paying close attention to their pet and are emotionally engaged. But it's not been clear until now whether this activity was mirrored in the dog's brain. In the current study, when humans were asked to pet the dog and gaze into their eyes, the inner brain activity between the two was even more connected than when they were merely patting or merely gazing at the dogs. Figuring out which brain was leading this rhythmic neutral dance. The humans or dogs, the researchers employed a special mathematical algorithm. Plugging in the data from each human-dog interaction, the team found it was the humans' brains that were initiating the coupled neural activity. Over the course of the study, the inner brain synchronization between the human-dog pairs grew, which suggests the two were bonding. Some scientists hypothesize that defects in social cognition, as seen in autism spectrum disorder, result from a reduced brain synchronization with others. I wouldn't say that. I didn't see this last part. To investigate this hypothesis further, researchers conducted the same experiment over again. But this time, the 9 dogs who showed similar characteristics to human ADS. In this case, the human-dog pair showed less inner brain synchronization, indicated reduced joint attention. Yeah, but they said this was... Do you not think that the ADS humans would also... Do you think ADS humans would bond better with ADS dogs? Well, these are ADS dogs, not actual humans that have autism. DSL has showed to enhance the social... Because autistic people seem to connect better with other autistic people. has been shown to enhance the social behavior of mice in previous studies. So researchers tried giving dogs with the characteristics of ADS a single dose of this psychedelic. LSD. The drug ultimately improved the dog's synchronization with their paired humans. Do not give me LSD! While studying, study is only small and further research is needed. These dogs could be a useful model for studying the neutral mechanisms underlying the social defects associated with ADS, the researchers say. Our findings suggest potential inner brain activity biomarkers for ADS diagnosis and development of engineered non-hallucinogenic analogs to LDS to correct social defects. Social defects. I am just fine. Also, I will not do LSD. One time, I actually tried, gummies with, weed gummies or whatever, and ended up having such a bad panic attack, we had to call emergency services. So, we're not doing that. A new study detects microplastics in the human brain tissue. Our microplastics problem isn't going away. These tiny fragments of plastic pollution have previously shown up in our lungs, in ancient rocks, and in bottled water. A new study reveals the extent in which they've infiltrated the brain, too. An international team of scientists looked at the oil factory bulbs, the masses of the brain tissue that take in smell information from the nose, in 15 deceased humans, and found the presence of microplastics in 8 of them. Researchers have previously found microplastics in blood clots, but this is the first published study to detect material in actual brain tissue. Another similar piece of research was now undergoing peer review. Yeah, it was bad. Like, I couldn't breathe. I felt like my heart was gonna explode. It just... no. Researchers have previously found microplastics in brain blood clots, but this is the first published study to detect the material in actual brain tissue. Another similar piece of research is now undergoing peer review. I'm gonna switch these two around just for... When microplastics have been detected in various human tissues, their presence in the human brain has not been documented, raising important questions about the potential neurotoxic effects and the mechanisms by which microplastics might reach brain tissue, write the research in their published paper. The researchers note that particulars and filaments were most common shapes, and polypropylene, the most common polymer. It's one that's most widely used in plastics, found in everything from packaging to car parts to medical devices. The particulate sizes range from 5.5 micrometers to 26.4 micrometers, no more than a quarter the width of a human hair. Previous research found that air pollutant particles make their way up the olfactory pathway. This latest study suggests that microplastics could be using the same route to the brain. Through the tiniest holes in the cribriform plate, just below the olfactory bulb. The identification of microplastics in the nose, and now the olfactory bulb, along with the vulnerable anatomical pathways, reinforces the notion that olfactory pathway is an important entry site for exogenous particles to the brain. Despite all these risks and health impacts, we don't seem to be able to cut down on our reliance on plastics, despite ongoing efforts to produce plastics that's more biodegradable. The fact that plastic production has doubled in the last 20 years. What's not clear yet is what damage these microplastics might do to our own health. Yet it's a safe bet that increasing concentrations of synthetic material inside the brain is not good news. Neuron damage and increased risk of neuronal disorders are likely based in recent research. There's also the nose connection to consider. A link between air pollution and cognitive problems has already been well established, and if microplastics are making their way into our nasal passage, it's likely to make matters worse. Some neurodegenerative diseases, such as Parkinson's disease, seem to have a connection with nasal abnormalities as initial symptoms. All right. Scientists identify a new blood group after a 50-year mystery. All right. When a pregnant woman had her blood sampled back in 1972, doctors discovered it was a mysteriously missing a surface molecule found on all other known red blood cells at the time. After 50 years, this strange molecular absence finally led researchers from the UK and Israel to describe a new blood group system in humans. It represents a huge achievement and the culmination of a long team effort to finally establish this new blood group system and be able to offer the best care to rare but important patients. The UK National Health Service hematologist Louise Tilly says, after nearly 20 years of personally researching this bloody quirk, while we are all familiar with the ABO blood group system, the rhesus factor, that plus or minus part, humans actually have many different blood group systems based on a variety of cell surface proteins and sugars that coat our blood cells. Our bodies use these antigen molecules amongst other purposes as identification markers to separate self from potentially harmful non-selves. If these markers do not match up when receiving a blood transfusion, these life-saving tactics can cause reactions or even end up being fatal. Most major blood groups were identified early in the 20th century. Many discovered since, like the ER blood system, first described by researchers in 2022, only impact a small number of people. This is also the case for the new blood group. The work was difficult because the genetic cases are very rare, explains Tully. Previous research found more than 99.9% of people have the ANWJ antigen that was missing from the 1972 patient's blood. This antigen lives on a myelin and lymphocyte protein, leading researchers to call the newly described system as MAL blood group. When someone has a mutated version of both copies of their MAL genes, they end up with an ANWJ negative blood type, like the pregnant patient. Tilly and team identified 3 patients with the rare blood type that didn't have this mutation, suggesting that sometimes blood disorders can also cause the antigen to be suppressed. MAL is a very small protein, which with some interesting properties making it difficult to identify, and meant we needed to pursue multiple lines of investigation to accumulate the proof we needed to establish this blood group system. Explains University of West England cell biologist Tim Satchwell. To determine they had the correct gene, after decades of research, the team inserted a normal MAL gene into the blood cells that were ANWJ negative. This effectively delivered the ANWJ antigen to those cells. The MAL protein is known to play a vital role in keeping cell membranes stable and aiding in cell transport. What's more, previous research found that the ANWJ isn't actually present in newborn babies, but appears soon after birth. Interestingly, all the ANWJ negative patients included in this study shared the same mutation. However, no other cell abnormalities or diseases were found to be associated with this mutation. Now that the researchers have identified the genetic markers behind behind the MAO mutation. Patients can test to see if their negative MAO blood type is inherent or due to suppression, which could be a sign of another underlying medical problem. These rare blood quirks can have devastating impacts on patients, so the more of them we can understand, the more lives we can save. All right, human singularity within just 6 years, trend shows. By one major metric, artificial general intelligence is most closer than you think. By one unique metric, we could approach technological singularity within the end of this decade. A translation company developed a metric, time to edit, to calculate the time it takes for professional human editors to fix AI-generated translations compared to human ones. This may help quantify the speed towards singularity. An AI that can translate speech as well as a human can change society. In the world of artificial intelligence, the idea of singularity looms at large. This slippery concept describes the moment that AI exceeds beyond human control and rapidly transforms society. The tricky thing about AI singularity, and why it borrows terminology from black hole physics, is that it's enormously difficult to predict where it begins and near impossible to know what's beyond this technological event horizon. However, some AI researchers are on the hunt for signs of reaching singularity, measured by AI progress approaching the skills and abilities compared to humans. One such metric, defined by Translate, a Rome-based translation company, is the AI's ability to translate speech into the accuracy of a human. Language is one of the most difficult AI challenges. I mean, look at English for a second. But a computer could close the gap. That gap theoretically shows sign of artificial general intelligence. That's because language is the most natural thing for humans, translated CEO Marco Trombetti said at a conference in Orlando, Florida in December 2022. Nonetheless, the data Translate collects clearly shows that machines are not far from closing the gap. The company tracked its AI performance from 2014 to 2020. 2022, using a metric called time to edit, or TTE, which calculates the time it takes for professional human editors to fix AI-generated translation compared to human ones. Over that 8-year period, an analyzation of over 2 billion post-edits, Translate AI showed a slow but undeniable improvement as it slowly closed the gaps between human-level translation quality. On average, it takes a human translator roughly 1 second to edit each word of another human translator, according to Translate. In 2015, it took a professional editor's approximately 3.5 seconds per word to check a machine-translated suggestion, and today that number is just 2 seconds. If the trend continues, Translate AI will be as good as human-produced translation by the end of the decade, or even sooner. The change is so small that every single day you don't perceive it, but when you see progress across 10 years, that is impressive, said Trombetti, said on a podcast. It's the first time ever that someone in the field of artificial intelligence did a prediction of the speed to singularity. Although this is a novel approach to quantifying how close human is to approaching singularity, this definition of singularity runs similar to the problems of identifying AGI more broadly. And while perfecting human speech is certainly a frontier in AI research, an impressive skill doesn't necessarily make a machine intelligent. Not to mention how many researchers don't even agree what intelligence is. Whether these hyper-accurate translators are harbingers of technological doom or not, it doesn't lessen Translate AI's accomplishment. An AI capable of translating speech as well as humans could very well change society, even if the true technological singularity remains ever elusive. Alright, and here's a stupid fun one at the very end. That was, of course, brought by Apocalypse. That she mentioned in one of my streams. And I might as well do it. Nasal packing with strips of cured pork as treatment for uncontrollable epistaxis in a patient with Gaussman thrombosis. Thosian. It is a rare, the Gasman is a rare disorder of platelet function that may result in life-threatening hemorrhages, particularly from the nasal vaults. Various medical therapies such as recombination factor 7, antifibrotic agents and blood transfusions, and surgical therapies such as nasal packing, electrocautery, laser coagulation, septoplasty, and embolization have been described with various degrees of success. Methods! We presented a unique case of a 4-year-old with known disease and 2 separate episodes of life-threatening hypoxias that were treated successfully by nasal packing with strips of cured pork because of special circumstances. Cured salted pork crafted as a nasal tampon packed with nasal vaults successfully stopped nasal hemorrhaging. Hemorrhage promptly and effectively and without sequelae. In both applications, the patient had complete cessation of nasal bleeding within 24 hours and was discharged within 72 hours of treatment. To our knowledge, this represents the first description of nasal packing with strips of cured pork for the treatment of life-threatening hemorrhages in a patient. Fun! Sorry, I had to do a stupid one at the very end. I know this isn't as long, but my voice, I don't think it's gonna last much longer, so that's the last one for tonight. Who will we torture? Who will we torture? No problem. I don't want an eternal sleep. I don't know what you're talking about. Alright. You're not allowed to eternal sleep. I'm not gonna let you. Alright, y'all, this was just Ciarfox. I hope you have a good day or night whenever it is, wherever it is you currently are. If you're watching this on YouTube, please like, subscribe, and comment.